Imagine someone reading 100 random words once. No repetition, no notes, no photographs, just one read-through in silence. And then, perfectly, in order, without hesitation, reciting every single one back. Now imagine the same person memorizing the order of a shuffled deck of cards in under 2 minutes, or learning 300 unfamiliar names and faces in a single afternoon. These are not scenes from a film. These are documented performances at the World Memory Championships, a competition held annually where human beings do things with memory that most of us would describe as simply impossible. And here is the question that should stop you. What if your memory was never the limitation? Every year, competitors arrive from dozens of countries, students, teachers, software engineers, artists, a postal worker from Germany, a teenager from Mongolia. Almost none of them would have described themselves as having a remarkable memory before they began training. Many described their memory before training as ordinary, average, sometimes frustratingly poor. And yet here they are, holding thousands of digits in their minds, constellations. For decades, scientists assumed these people possessed something the rest of us lacked, a rare gift, a neurological anomaly, a different kind of brain. But when researchers began studying memory champions closely, scanning their brains, interviewing them in depth, what they discovered was something far more interesting than genetic advantage. Almost every single champion was using the same technique, like a technique so old that the civilization that invented it no longer exists. The year is 477 BCE. On the island of Ceos, in ancient Greece, a poet named Simonides has been invited to perform at a banquet held by a nobleman named Scopas. The hall is full. Guests are seated at long tables. The wine is poured. Simonides performs his ode and then steps outside for a moment. He has barely crossed the threshold when the roof collapses. The entire structure comes down. Stone, timber, ceiling, table. Every guest inside is buried, crushed beyond recognition. When rescuers arrived, there was a problem that seemed insurmountable. The bodies were unrecognizable. But Simonides remembered. He closed his eyes, and he could see the room exactly as it had been. The long tables, the arrangement of the guests, who sat next to whom, where each face was positioned in the space. He walked the rescuers through every seat, every name, every location, and in doing so gave the families of the dead the ability to bury their own. What Simonides realized in the aftermath of that tragedy was not a coincidence. It was a discovery about how memory actually works. He had not remembered the guests by trying to memorize their names. He had remembered them because they had somewhere to be. The brain remembers places long before it remembers words. This was a precise insight about the architecture of human cognition that modern neuroscience would take 2.5 millennia to fully explain. Deep within the hippocampus, the seahorse-shaped structure at the center of memory formation, there are neurons that fire specifically in response to location. Neuroscientist John O'Keefe discovered these cells in the 1970s and called them place cells. What they revealed was that the brain doesn't just move through a space, it maps it constantly, automatically, with extraordinary precision and virtually unlimited capacity. When you enter a room, your hippocampus begins constructing a representation of that space, the layout, the proportions, where things sit relative to each other. A navigational model so detailed that you can move through the room in complete darkness, and so durable that you can recall the layout of a childhood home decades later. Working alongside place cells is a second system, neurons in the entorhinal cortex, that create a coordinate grid across every environment you inhabit, an internal GPS that the brain lays down automatically, everywhere, without effort. Together, they form what neuroscientists call the cognitive map. And here is the crucial insight. When the brain stores a memory inside a known location, it uses that spatial scaffold to retrieve it. The place becomes the address. You don't search your memory for a word. You walk to where you left it. Knowledge becomes unforgettable when it has somewhere to live. In 2000, neuroscientist Eleanor Maguire at University College London published a study that sent reverberations through memory research. She had scanned the brains of London taxi drivers, people who had spent years memorizing the labyrinthine street network of one of the most complex cities in the world, a process requiring a notoriously demanding test known as the knowledge. What she found was measurable structural difference. The posterior hippocampus, most associated with spatial navigation, was significantly larger in the taxi drivers than in a matched group of non-drivers. And the longer someone had been driving, the more pronounced the difference. The brain had physically changed in response to intensive spatial memory use. When Maguire later studied memory champions performing in an MRI scanner, the regions that lit up most dramatically were not those associated with rote learning or verbal memory. They were the regions associated with spatial navigation and visual imagery. The champions were not memorizing lists, they were taking walks. A 2017 study in Neuron by Martin Dressler and colleagues confirmed what Maguire's work had suggested. 40 people with no memory training whatsoever. One group received 6 weeks of instruction in the Method of Loci. The other received none. At the start, both groups performed similarly. At the end, the trained group had more than doubled their memory performance, and their brain connectivity patterns had shifted to resemble those of expert memory champions. 6 weeks. No genetic advantage, no special education, a method, a palace, a place for every thought to live. This is what Simonides had discovered in the wreckage of a collapsed banquet hall, what the ancient Greeks systematized into a practice they called the Method of Loci. Loci, the Latin word for places. The technique is elegant in its simplicity. You begin with a space you already know perfectly, your home, a route you walk often, any building you can close your eyes and move through with confidence. Then you take whatever you want to remember and place it somewhere in that space. Not abstractly, vividly, with texture, movement, and absurdity. You want to remember the word revolution? Picture a spinning wheel the size of a car lodged in your front doorway, sparking against the frame. You want to remember the number 7? Imagine 7 enormous golden candles dripping wax across your kitchen floor. The stranger, the image, the more the brain notices. The more it notices, the deeper the encoding. When the time comes to retrieve, walk the route again in your mind. Each location is waiting. Each image is there. Not because you forced them in, because you gave them a place to live. You don't build a memory palace. You discover the one your brain has always been waiting to use. And now, return, one final time, to the ceiling of the Sistine Chapel. Michelangelo spent 4 years lying on his back, painting a story across 500 square meters of ceiling. He did not paint it as a list. He organized it as a space, scenes arranged in sequence, characters placed in relation to each other. The eye moving from panel to panel, the story unfolding as a journey through a designed environment. Consider the ancient Greeks. who built theatres carved into hillsides and who used those same hillsides in their minds as theatres for memory. Consider the hippocampus, which has been mapping spatial environments for millions of years, long before humans had language, long before we had the concept of remembering at all. 3 things: ancient Greece, the Sistine ceiling, the architecture of your own mind. All 3 arrived at the same discovery from different directions. Memory is not a vessel where information is poured. Memory is a place where meaning chooses to remain. The gap between Michelangelo's fingers is not just a metaphor for consciousness, it is a metaphor for the space between a thought and its home. The moment before something is placed, before it has a location, a room, a wall to lean against and light falling across it at a particular angle, it is at risk of vanishing. But the moment it belongs somewhere, it becomes part of the palace. And the palace, as Simonides discovered in the silence after the stones had fallen, does not forget. The oldest technology for remembering was never language, it was architecture. Every neuron remembers, every thought changes you, every choice rewrites you. The gap is still there, the spark is still crossing, so become.